Oops, sorry about the arm. Okay, gosh, I hope the sound is coming on now. So I promised you that I would have one video of one of the review packets. I can't do all three of them, but at least I can give you a video for one. So I've selected video 2. All right, here we go. 1A, name in all possible ways the line containing A, R, and D. So here's A, here's R, here's D. So I can go AR, make sure you have the symbol, RD, AD, and then you just reverse each one. RA, DR, and DA. So you can name that 6 different ways. The sides of A, B, C. A, B, C. So B is the vertex, so the sides would be Ray, BA, and Ray, BC. All right, what side do angle 2 and 4 have in common? Here's 2, here's 4. They both share this segment right here, DE. So you can call that segment DE. Name the horizontal ray with endpoint C. Horizontals are always going left to right like this, and the endpoint is C, so it must start at C and go through B. Answer, ray CB. Our angles FCD, which is this one, and DCE, different angles. DCE. Are they different? No, because they have the same vertex and they use the same sides. Which angle in the figure is B? Well, can't tell, because there are actually 3 different angles that have a vertex at point B. Angle 1, and angle 3, and ABC. So it's too many. All right, ray EC, so it starts at E and goes through C, in union with FA, starts at F. Those two together form a line. There are a bunch of ways you can take any 2 points on that line and name it, one of which is AC. Ray EC starts at E, goes through C, and this time intersects FA. Now I'm only interested in this overlap part, so that's FE or EF, either one. BA and BE. So here's BA, BA, BE. That forms an angle, angle ABE or EBA. Line AC and line DR. Line AC and line DR. Even though it is called line DR, since it's a line, it goes forever, which means it does intersect at point A. Angle AFD. AFD, that's this angle here. And segment CE. Okay, so here's the segment. Here's the angle. The only place those overlap is at EF. Okay, different colors might help too. 2A, now we're going to add using degree minute second notation. So 43 degrees, 15 minutes, 17 seconds, plus 25 degrees, 49 minutes, 18 seconds. When I add these together, I get 35 seconds. 5 and 9 is 14, 64 minutes, which already my little alarm bells are going off because this right here is more than 60. So I'm going to take 60 of those minutes and turn it into a degree. I have 4 minutes left over, and I still have 35 seconds. 90 minus 39.17. 90, let's prove 0 minutes here, minus 39 and 17. I'm going to have to borrow a degree here, so I'm going to change that to 89 degrees and change that to 60 minutes. 60 minus 17 is 43 minutes. 89 minus 39 is 50. So there's that answer there. 46 and 7/8 are degree minutes and seconds. So you're going to take the portion here, 7/8, and multiply that by 60. And that's going to be, I'll get the calculator out, 60 times 7 divided by 8 is 52.5. So this is, oh, no means video. Okay. 60 degrees and 52.5 minutes. But now you also have to take the 0.5 and multiply by 60. So the final answer is 60 degrees, 52 minutes, and 30 seconds. If you're lucky enough to have the 0.5, then I would just put the 30. 3b says now we're going to change this to degrees. So we have 132 degrees and 6/60ths of a degree. So now you're going to divide by 60. 6 divided by 60 is 0.1. So this is 132.1 degrees. All right, that was page 1. Next. According to the diagram, which two segments are congruent? So I'm going to look at the tick marks here, and it looks like BC and RT are congruent. So BC and RT. Which angles are congruent? So I'm looking for angles that have the same markings. These are not congruent because they're marked differently. But A and S are marked with the same marking. So that means angle A and angle S. Next one. If A is congruent to B, which means these are the same measure, what is angle A? Well, algebraically, I'm going to go 2x plus 5 equals 50 minus 4x. Add 4x to both sides. Subtract 5 from both sides. I get 6x equals 45. X equals 7.5. And then the measure of angle A would be 2 times 7.5 plus 5. So what is that? 15 plus 5? 20 degrees. Number 6, complete the proof. So this is kind of nice. You have some statements that are written for you, and we're going to do the reasons. Given diagram is shown. Prove that angle EFG, oh my goodness, that's a straight angle, is congruent to HJK, which is also a straight angle. That's probably going to be important. Statement 1, given. Statement 2, EFG is a straight angle. You can assume that from the diagram, or you can just write the word assumption. 3, straight angle, assumption. And so now they're congruent because if two angles are straight, then they must be congruent. And that's it for that one. 7, trisecting. So DF and DG trisect this big angle. So all three of these are congruent. Oh, look at that. Prove all three of these are congruent. So that's a two-stepper. Number 1, ray DF and ray DG trisect angle EDH. Reason? Thank you very much. Given. 2, angle EDF is congruent to angle FDG, which is also congruent to angle GDH. I don't like GD. Because if two rays trisect an angle, then they form 3 congruent angles. Okay, another proof. Given AB is congruent to BC, I always mark stuff as I read it. AB is congruent to BC. Prove that B is the midpoint. All right, well, I believe B is the midpoint because the segments on either side are congruent, so that makes sense. AB is congruent to BC, given. And number 2, B is the midpoint of AC because if two segments are congruent, which is what I said here, then the point which divides them is the midpoint. There we go. Oh, another trisection. All right, given OR and OS trisect TOP. So that is congruent to that, is congruent to that. TOP is 40.2. Oh, that's nice. Okay, so 40.2 is the whole angle. So all I have to do is divide that by 3, right? So I want POR. So 40.2 divided by 3. Boy, can we have like 100 of these problems on the test tomorrow? 13.4 degrees. Oh, well, my favorite, the clock problems. Alright, 1:15. I don't know about you, but I do still draw the picture of the clock. Still helps. Alright, 1:15. So that means the minute hand is going to be here. And the hour hand is going to be a little bit between the 1 and the 2, but closer to the 1 than to the 2. So it's not even like 30. Oh, wait. Between 2 and 3 is 30 degrees, right? And then you need this part right here. Well, this small part here is 15/60ths of 30. So that means my other part is 45/60ths of 30. So I'm going 30 degrees plus 45/60ths of 30. So 30/60ths is a half. Half of 45 is 22.5. 30 plus 22.5 is 52.5 degrees. 4:45. 12, 3, 6, 9. Alright. Minute hand is going to be here. Here's the 4. Here's the 5. The hour hand is closer to the 5 than it is to the 4. So again, I want the small part here. So this is 30, 60, 90 degrees in here. This is 30 degrees in here. And this again is going to be 15/60ths. So we have 120 degrees plus 15/60ths of 30. So it's 120 plus 7.5, which is 127.5. Alright, so now we're taking a turn here. Write the converse, inverse, and contrapositive. Alright, so here's your statement. If the time is 2 o'clock, then the angles formed by the hand of the clock is acute. Well, that's true. Converse means you're gonna interchange both parts. If the hands are acute, then the time is 2 o'clock. Okay, that's false because you can certainly have other times that have acute angles between the hands. It's not necessarily just 2 o'clock. The inverse is when you basically put a not in front of this statement and a not in front of this one. So if the time is not 2 p.m. or 2 a.m., then the angle is not acute. Well, that's false again too, because that's what we said. If the time is not 2 o'clock, that doesn't mean the hands aren't acute. It could be some other time and still be acute. Contrapositive. If the hands, the angle, we'll call it, is not acute, because now we're reversing and nodding, then the time is not 2 o'clock. And that is true, first of all, because it's a contrapositive, we know it has to be true. And second, because obviously if the angle is not acute, it can't be 2 o'clock. Alright, I'm going to squeeze one more in. Can I squeeze one more in? One more. Perimeter. If the perimeter of PRST is 10 more than 5 times RS, actually I think I'm going to save this for another video. So we'll have a second video that starts at 12. So this is going to be end of first video. Okay.